It is yet again we come to a concept: spooky action at a distance. Physics should represent a reality in time and space, free from spooky action at a distance. Well, what is spooky action at a distance? I guess in layman's terms, which is all that I am, is a layman. Therefore, the only understanding I have of physics or quantum physics is that in layman's terms. Well, let's see what we can explore here. Einstein's spooky action at a distance comes from something that he wrote to Max Born, which coined this memorable phrase that I guess I'm realizing synonymous with Einstein. The average person may just think of E equals mc squared and maybe some other quirky quotes from Einstein, but more and more I associate spooky action at a distance as maybe one of the most profound things that Einstein uttered, because it touches upon something that, in my view, is still as mysterious as when Einstein was grappling with it in the 1930s. The full sentence is: physics should represent a reality in time and space, free from spooky action at a distance. And to illustrate this point, if you are unfamiliar, and to help me understand it better, because I am just a layman in layman's clothes, trying to come to terms with some of these concepts which are crucially important to existence, but yet one can be like myself and live your entire life not ever encountering people grappling with these ideas, which really makes me wonder what the heck it is that we're all doing in life and we think is so important, doing our jobs and pursuing our careers and not trying to understand the nature of reality. What is spooky action at a distance? This is quantum physics. Okay, so at this time there was something called the Copenhagen consensus, which was Niels Bohr and Heisenberg, who were from Copenhagen, and there they were exploring quantum mechanics. This was sort of the hub of quantum mechanics. Werner Heisenberg, Max Born, and others. Einstein wrote a paper in 1935, which he collaborated with two others. It was called the EPR paper. Einstein, Nathan Rosen, 26-year-old, and Boris Podolsky, 49-year-old physicist. They collaborated on this paper. It was only a 4-page paper, which you can find online. And according to this biography of Einstein, was his most important paper Einstein would write after moving to America, which means his most important paper that he would contribute to for the rest of his life after 19-whatever, when he moved to America in 1933, in which he would never return to Europe for the rest of his life. Okay, so a definition of terms here, perhaps? What was the paper? How about that? The paper was a thought experiment on Einstein's part, which is what is so cool about Einstein, is just that he pursued ideas through thought. You know, it's the greatest example, one of the greatest examples that everything in existence is generated in the mind. The human brain is capable of transcending and grasping the nature of reality. And this is what Einstein was bent on, is that there was a nature of reality, that there was a tried and true existence, that there was laws of nature, laws of physics, and that when something was discovered that appeared to violate those laws of physics, it had to be wrong. And that was his beef with quantum mechanics. Now, the paper Einstein had some issues with. He thought that the other two folks that he was collaborating with pushed the mathematics mathematical formalism to be ahead of the concept that he was promoting, and so he complained that it was smothered by formalism. I dropped my pen. Okay. If we could learn with absolute certainty the position of a particle, and we have not disturbed it by the particle, have not disturbed the particle by observing it, then we can say that the particle's position is real, and that it exists in reality totally independent of our observations. What quantum mechanics said is that a particle exists in superposition. It exists in all possible positions at once until it is observed. And so I think philosophically, it is kind of like if a tree falls in the woods and no one was there to see it, did it really fall? It implies that until something is observed, it exists in every possible state simultaneously. And we'll get to Schrödinger's cat in a moment here. Einstein was concerned with this for a few reasons. One is the concept of locality, which means that an action involving a particle cannot influence a particle in another part of space unless something travels the distance between them. A process limited by the speed of light, right, which is the speed limit of the cosmos, okay, the speed of light. Now, for one particle over here to influence another particle over there, information of some sort must be passed between the two. So, where does that come into play? Is that quantum entanglement? I feel like there's two concepts here. One is that the observer, as I just mentioned, collapsing the superposition of a particle, and then there's this particle over here influences that particle over there without communicating. Okay, let's just keep reading. Oh man. Okay, so what it is that two particles are entangled. You observe one or measure one. I'm also confused in, I believe, observation and measurement in terms of quantum is the same thing. Observing something is measuring it, okay? And so observing one particle reveals the position of the other. And so that is implied that this particle, once it is observed, somehow affects this other particle, which could be on the other side of the universe at the same time, which would violate the speed of light because no information could travel instantaneously because nothing can travel faster than the speed of light. But I guess the modern understanding is something like it doesn't violate the speed of light because there was no information being shared between the two. It is simply revealing what is the predetermined state of the other particle. And then Schrödinger's cat kind of explains this, which this details here actually that Schrödinger and Einstein were in communication with each other. On one issue, Einstein and Schrödinger diverged. Schrödinger did not feel that the concept of locality was sacred. He even coined the term that we now use, entanglement. Let's fucking highlight that. Entanglement. To describe the correlations that exist between two particles that have interacted but are now distant from each other. I will also say here that when we're talking about particles, I believe this is the smallest thing besides what string theory deals in. This is smaller than atoms and smaller than molecules, right? So I've tried to, and I forget the scale here, but thinking about mitochondria and the level of mitochondria to cell, right? So mitochondria being smaller than cells because mitochondria are inside of the cells, and understanding this scale is really mind-boggling. And then we have particles that are underlying all of those even smaller yet. It's like, damn, okay. Schrödinger's cat is something like a cat in a box Why not? A cat in a box. The cat in the box is both dead and alive at the same time until somebody opens the box and measures the cat or observes the cat. And then when you open that box, it's either dead or alive, and then it's settled. It's dead or it's alive. But until you open that box, it exists in a superposition of being dead and alive at the same time, going back and forth between those, just all of this stuff all at once, everything all at once, until you open the goddamn box and reveal if the cat is dead or alive. That is kind of Schrödinger's cat in a nutshell. And Einstein was thrilled. He said, "Your cat shows that we are in a complete agreement concerning our assessment of the character of the current theory." He wrote back, "A PSI function that contains the living as well as the dead cat just cannot be taken as a description of a real state of affairs. The case of Schrödinger's cat has spawned reams of responses that continue to pour forth with varying degrees of comprehensibility." No kidding. Suffice it to say that in the Copenhagen interpretation of quantum mechanics, a system stops being a superposition of states and snaps into a single reality when it is observed. But there is no clear rule for what constitutes such an observation. Can the cat be an observer? A flea? A computer? A mechanical recording device? There is no set answer. However, we do know that quantum effects generally are not observed in our everyday visible world, which includes cats and even fleas. So most adherents of quantum mechanics would not argue that Schrödinger's cat is sitting in a box, somehow being both dead and alive until the lid is opened. Time to shelf the book and stop thinking about quantum mechanics. What is one final thought to put a pin in this madness? Einstein hated quantum mechanics, and I'm starting to hate it too. Somebody said, maybe it was Richard Feynman, that a paraphrase of the quote is, "I think it is safe to say that nobody understands quantum mechanics." And for Einstein to go to war with the Copenhagen consensus, I resonate with that so much because it kind of boggles my brain. But I also believe that these are things that we can come to reason with, but more of us need to try to grasp them and try to understand them. To make a fool of ourselves by talking about these ideas out loud, then to check our ideas with tools like AI, but then to remember that a lot of these are unanswerable things that even the greatest minds of our times have not come to a consensus with. That's kind of cool. It can be fun, interesting. I think we should all try our hand at trying to understand and grapple with these concepts, and then to look towards the future and that we'll have a better understanding of these things. It's kind of fun, you know? So anyways, cheers to quantum mechanics. It also, I think, I wanted to juxtapose this with around that time, you know, in the late 1930s when Einstein was grappling with these things. The world was at war. The world was going to war. There was different ideologies battling in physical reality, right? So we have this sort of metaphysical space where we can have these battlegrounds of ideas, quantum physics versus classical physics, and then it all is, you know, sort of juxtaposed with the reality that we face, which is our ideologies manifesting themselves in physical reality in war, right? So different ideas on the battleground of humanity, of Earth, and then these metaphysical ideas that are in the battleground of our own mind, and at the fucking quantum level of particles and all that stuff. So it's the same stuff going on today, old Einstein. Ain't shit changed, as they say. Ain't shit changed.